So let's just get to it. The first technique that we want to see is called zip, and well, I guess the name comes from zippers, probably. Have not actually researched that one, but basically it allows us to operate with different containers at the same time. Lists are containers and there are others, but let's see an example. Suppose we have here a list called captains that contains some Star Trek captains: Kirk, Picard, Janeway, and Rios. And let's suppose we'll have also another container, which in this case, as you can see by the round parentheses, is actually a tuple. So we have two containers, a list and a tuple, and we want to combine them. And we want to do something very simple. We want to create a new list of tuples that contains in each position one tuple, which first element the corresponding element in the list, and second element the corresponding element in the tuple. So basically, instead of having the list on one hand, the tuple on the other, we want to push this in and have a list with pairs, and each pair will be the name and the number, which corresponds to the evaluation that someone has made of this Star Trek captain, the one they like best. We can do that very simply with a for loop, for example. We will define our list to be named merged, because we want to merge these two containers, and we will have a regular run-of-the-mill for traversal loop. For I in range of the length of the list, we will append a new element at each position, and what we will append will always be the element that we are traversing in the list put inside of a tuple with the element in the same position of the evaluation tuple. And if we run that, we get a list that contains what we were hoping for. At each position it has a tuple. The first element in each tuple is the name of the Star Trek captain. The second element in the tuple is the evaluation, the corresponding evaluation. Okay. So this is something that we can do using regular for loops. And everything works fine and everything is perfect, no problem. You can do this if you want. Okay, and probably that would be my first impulse to someone who learned to code in a language that was not Python. But as it turns out, Python has its own characteristics, and one of them is that it tries to use for loops as little as possible. The reason for this is that for loops are very, very general, so you can use them to do lots of different things. But they are very often used for very similar purposes, and Python tries to identify some of those very repeated patterns of use of for loops and codify them differently so that they can make them faster. Okay? For example, this one here, using a for loop to iterate more than one thing, more than one iterable in Python parlance at the same time. Okay, we can do that with a for loop, but we can do that also using zip. Zip is a function in Python that returns just an iterable object. So let me define zip. I need to give it some arguments, which are always things that can be iterated themselves. Okay, and when I use zip on them, what zip does is that zip puts together, groups together all the things that I have given it, all the iterables that I have given it, and makes them into one single iterable. I have 2 here, but I could have 3, 4, 5, as many as I want. Okay, so that's what I have done. I have created a zip object with the 2 iterables, captains, which is a list that can be iterated, and evaluation, which is a tuple that can also be iterated. And I can print the type of this object, of this zip object that I have created. Once I have this, we can use this iterator, this zipped object that we have created, to iterate at the same time over all the iterables that I have. Okay, so for example, I could just have another 4 and use it to print what I was printing before. I haven't had to do this 4, I just said zipped, and I get something that allows me to do the same thing. Okay, so let's see that. First of all, zipped, I have printed its type, and Python is telling me that it's something called zip thing. So it's one of these objects that allows me to iterate different things at the same time. And then, using it, I can just print the information that I was printing before, similar with this print function. The captain Kirk, the captain is, and I get the first element in my iterator, which corresponds to the captain's list, and their evaluation is, and I get val, which is the second element in my iterator, which corresponded to evaluation. So zip has transformed 2 different iterable objects into one joint iterable thing. Okay, I haven't reinvented the wheel or anything here, but it's very convenient. Instead of doing this 4, I can obtain a similar result with just this line, zip. Notice that this is an object that allows me to iterate things, but iterators only work once. Okay, so if I try to iterate a second time, and say second iteration every time I get a value in zipped, I don't print anything, because once I have iterated zipped once, it's become empty. Okay, so zip returns me an object that allows me to go over once over a list of iterables, a series of iterables, some iterables. Okay. An important detail is that zip only allows me to group together, to iterate together things that have the same length. So if we look back at the original, the same length. So if, for example, here I create a new list of captains that has Kirk, Picard, Janeway, Rios, and Spock, a new one, and I maintain the same evaluation with only 4 positions, and I do the same thing where I first create a zip object for captains and evaluations to be iterated together, and then we could create a list as before. We can create a list also just using the list creator. Okay, so if I run this and print it, I get a list of tuples as I was doing before. No need to use the big 4. Just with this I get my result, and I can print it, and I get Kirk, Picard, Janeway, Rios, and no one else, because zip is only considering the elements that, the number of elements that are present in the shortest iterator. Okay, so the last element in the captain's list has been ignored. I can do something a little bit more sophisticated. I can consider elements that are not present using something similar that's called zip longest. And I have to import it from some library called itertools. And if I do that, then I can iterate over different iterables. I have a list, a tuple, and another list of ships. And then instead of zip, I use zip longest, and I can give it something called a field value. So group together all of these things, and when you don't know what the value should be because one list is shorter than the others, then you use this value that I'm giving you. In this case, it's a string only containing the interrogation symbol, question mark. Okay. And if I define zipped as the zip longest of these three things with this field value and just create the list with those things, I get the list with tuples, 3 elements in each tuple because I'm zipping 3 things here. And whenever I don't have a value, for example, the 1, 2, 3, 4, 5 evaluation, so the evaluation in position 4, fifth one, I will get a question mark. And for position 5, so the 6th position, I don't have either a name of captain or an evaluation, so I get not 1 but 2 question marks for discovery. Okay. So zip allows me to traverse different iterable things, lists, tuples, could be dictionaries, could be iterable things that I have defined with my growing object-oriented programming capabilities. I can traverse them together at the same time with zip and do very convenient, very fast things like put them all into a list with a very short code. Okay. I can also use zip to unpack things. The same logic, I can use it to undo this coupling together of things, putting together of iterables. To do that, I use the asterisk operator in order to unzip this. So let's suppose I have a list called pairs that has, well, pairs in them, tuples with 2 elements. I can use zip and the asterisk operator with pairs so that I would get 2 different lists, 2 different iterables, numbers and letters, and then I get them both as tuples in this case. Okay, so I'm doing tuple unpacking in this case with the star operator, the asterisk operator on steroids because zip allows me to do it over iterable things.